This section, we're going to talk about combinations. Remember the other section when we're talking about permutations. Permutation is the one when it say the order is matter. So this section's combinations is when order is not matter. And the formula for the combination is, again, out of the total outcomes and whatever the case outcomes will be R, right? So combination of n, R is n factorial over n minus R factorial time R factorial. Let's looking at the example 1. Three-person committee is needed to study way of improving public transportations. How many committee could be formed from the 8 people on the board of supervisors? So this problem, we can see that this is going to be combinations because order is not matter. Why is it order matter? We're picking 3 people. So picking A, B, C will be the still same as if we are picking B, A, C. So order is not matter here. So we had one of the example from permutation saying that if we're picking CEO, manager, and treasurer, order is matter because A can be CEO or A can be treasurer, right? Depends on where A is going, the order is going to be matter. This one, you're just picking 3. So any order of 3. That's why it's not order matter. So in that case, we're going to use the combinations. Let me do the blue, right? Combination of, out of the total of 8, you're picking 3. Then you get 8 factorial over 8 minus 3 factorial times the 3 factorial. Again, you should be able to use calculator to do all this, but if not, we know that this is going to be 8 factorial over 5 factorial and 3 factorial. So then I'm going to get rid of the bigger factorial first by getting rid of 5 factorial from 8 factorial. Then you end up getting only 8 times 7 times 6 remaining, and then you have 3 factorial, which is 3 times 2 times 1. I guess you can eliminate before you multiply. So this 3 times 2 right here, 3 times 2, which is 6, we'll get rid of that. And this will be same as 8 times 7, which is going to be 56. Let's look at another one. How many different 4 cards hands can be dealt from a deck that has 16 different cards? So out of 16 cards, you're trying to pick 4. And this one, again, I will say order is not matter. Why? Because it's going to be the same having, let's say, heart 1, 2, 3, 4, which is those 4 cards, will be the same as if I have heart 4 first, and then 3, 2, 1. It will be still 4 cards, right? 4 of the same card. So order is not matter on this one. So we're going to use combinations. How many cards? Total 16, and you're picking 4. So then you get 16 factorial over 16 minus 4 factorial times 4 factorial. So this is 16 factorial over, that will be 12 factorial times 4 factorial. So this 12 factorial will cancel out 16 and leave 16 times 15 14 and 13 over 4, 3, 2, 1. And look like you should be get rid of 4. And then you can also get rid of 4, become 2. And 3 cancels out 5. So in other words, this is going to be all same as if you're multiplying 2 times 5, which is 10, times 14 times 13. And easy enough, you can do by hand, or if you don't want to, use the calculator and you get 1820. So now we know how to use the combination formulas, right? So long as you can tell if it's permutation or combinations, we have a formulas to use, so we should be able to get solution out of it. So then let's look at example 3. Example 3 is asking, well then, are you be able to determine whether the problem is permutation or combinations, right? Example A, it's a how many 4-digit numbers are possible if no digits are repeated. So if you're not repeating the digits, let me give you an example for it first. So it means that 4-digit numbers. So I could have 1, 2, 3, 4. 1,234. But using the same number, if I use 2 first, is that going to be same number? No. So that's how I know this one order matter. So order matter, then it's going to be permutations. What about then looking at example B? A sample of 3 light bulbs is randomly selected from a batch of 15 bulbs. How many different samples are possible? So when we're picking 3 bulbs, does that matter if we have bulb A, B, C or BAC? Is that going to be different? Yeah, because this one is looking at it as a group, like 3, group of 3, right? So it doesn't really matter if I have ABC or BAC order of the bulb. So this is going to be order not matter, and order not matter, it's going to be combinations. Let's look at example C. It's in how many ways can 4 patients be assigned to 6 hospital rooms so that each patient has a private room? So is that going to be, let me picture this. So you have a 6 hospital room. Let's do that. 6 hospital room. 1, 2, 3, 4, 5, 6. 6 rooms. So if I put A here and B here, is that going to be, and so on. But is that going to be same if I put B here and A there? No, it's different. Different person was going into different rooms, so that's going to make it different. In this case, again, we will say this is order matter. So order matter, your answer is going to be permutations. Let's look at D. In a race in which there are 50 runners and no ties, in how many ways can the first 3 finish come in? So first 3. So first place, right? It could be first place, second place, and third place. So if I put A here, B there and C, is that going to be same if C become the first place and A second and B third? Well, that's going to be different case, right? The same people but different case because C become first instead of third from the other one. So order matter on this one. So again, permutations.